Okay, welcome to Calculus in the AM. I'm your host, Mr. Shidaka. Relative and absolute extrema. It's not a bad section, but before we start, a message from our sponsor, me, Papa Joe's Farm Fresh Organic Eggs. Each one of our eggs are individually examined. It's my father there, actually, on the left. Carefully, so that there's no cracks. They're all perfect. And I'll deliver you nature's kinder surprise each and every time. Eggs so delicious, you want to eat them again and again. Quality guarantee from a name you can trust. Me, Papa Joe. That's my papa, about 40 years ago. Isn't that a cool shirt? I grew up where I used to raise chickens and stuff like that. So it's in my blood. Anyways, back to me. Relative extrema. Now let's read through this, because part of the thing next year, if you're taking a math class, calculus, is sometimes people complain, oh, my prof was terrible, and all this stuff, they just went on. You know what, you're going to spend some time reading your textbook, so that's why I include this stuff here. Can you sort out what the heck they mean when you read a rule or something like this? Because sometimes you're going to have to teach yourself, and group up with some people that seem to be, you'll know within a month if they're good students or not to work with. Do that too. Sometimes you got to struggle through some things, in not just a math class, a physics class, an engineering class, whatever. So, if you're given this relative extremity, let's see if we can figure this out. A function is said to have a local or relative maximum value at c. So x equals 5 or something like that. If there exists an open interval containing that number c, on which the function is defined, and the function is smaller than or equal to the value you get at c. So when you plug in 5, maybe you get 17. Everything else is 17 or less. That makes sense. Then that means that f of 5 equals 17. 17 would be the maximum value for all values of x in the interval. Figures 1 and 2 show some relative maximums at x equals c. Okay, well, let's see here. This is quite obvious. This is a maximum value on this interval, right? And in figure 2, it's pretty easy too. Now, something that's also note that in. The derivative at this point c here would equal 0. That's important. The derivative here doesn't exist because if you approach it from the left, you approach it from the right, you get two different values, right? That's important because that's basically how you find these. You find the derivatives. Look, where is it c? Where is the value 0, or where is the value not existent? Those are possible, only possible, max or mins. Call those critical points. Now, the reverse discussion for a minimum. These look like minimums. And you see on the right, the derivative doesn't exist at that corner, right? The derivative is 0 at this point. But those are minimums, and we know what they look like. So I'm not going to read through the relative minimum. It's the opposite discussion. But let's just take a look here. So flip your page. Now we've used the word relative only. And relative means in its neighborhood, like just in that general zone. Absolute extrema are different. This function above has relative extremes, a relative maximum, a relative minimum, but no absolute maximums or minimums. Like, just take a look on the right-hand side of the graph. This implies that this goes up forever. So it has no maximum value for this function. This tells us that this goes down forever. No actual absolutely smallest value for that function. But you see in this neighborhood here, there's a maximum there, and it happens that the derivative is equal to 0. Let's mark these in here. Notice that all extrema, maxes or mins, relative maxes or mins, occur where the derivative is either 0 or undefined. We call these critical numbers. So do you see that there's at -1, there's a critical number because there's a maximum there, and the derivative's equal to 0. I want to just Put a dot there, that's 1. There's a critical number at positive 1. That's where the derivative is equal to 0. Just jot that in there. There's a critical number at 1, 2, 3 because the derivative doesn't exist, but it turns out that the function is a maximum there. What do you guys say at 6, 7? Definitely a minimum there, right? A relative minimum. Does the derivative exist there from the basis of that picture? What do you think? Is it a 0 or is it a non-existent one? Take a look from the left, take a look from the right. What do you think? You know what you're considering? It doesn't exist. Why not? It's a slight corner. It's not as like pronounced as this one. Like, that's no question. Do you notice this curve here kind of suggests that tangent line at that spot as you approach it, 7. And this one kind of suggests this. The derivative doesn't exist. From the left and the right, you get 2 different values. Now remember, when you're doing derivatives, you're actually doing a limit question, right? We just have a shortcut for it. And that derivative, which you guys described really well, is just a, once you get that, it's a formula that gives you the slope of the tangent line. At any given point you plug in for x. Okay. Let's try this. The domain of the function f. So remember, that's like the what? Is all real numbers. If the derivative, so I'm giving you guys the derivative. I've done the derivative step. Is equal to this expression. What are the critical numbers for the function? Okay, you guys good on this? You understand what it's doing? So often you'll be given a function, find the derivative, and then find the critical numbers. What do we know about critical numbers? What do we need to do to find critical numbers? What are we looking for? Just look above at your diagram, where the derivative is either which value? 0 or not defined. Here we could possibly have one of each. For this function to be a 0, we need 0 out of 5, 0 out of 12, 0 out of anything except for 0 out of 0. That's called indeterminate, right? So really, as long as we don't have 0 on the bottom, we need to just solve for the numerator to be 0, right? Then, where does the derivative not exist? I think you can see this. You can't divide by 0, right? It's a cube root, 1/3. So you can have negatives in there, right? Because the cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2. That works. Okay, then what? Well, let's just, I think the easiest one is to do the denominator and say the derivative doesn't exist. Okay. So critical number at x equals 0. Sits since the derivative doesn't exist at 0, right? I'm going to just put in brackets here. How did we decide that? Because I said it out loud. I'll just say x can't equal 0. Oh, that's switch hands. For this. Now, the original function, it could have equaled 0. Okay? We were told that. There's a critical number at 0, and then we've got to set the numerator on fire there. Right? So setting the numerator 0 from the derivative, like x squared minus 4x minus 5. We just got a factor. And I sure hope you remember. Okay, x, what multiplies to negative 5 adds up to minus 4. So it'll be more negatives, 5 and 1, right? More negatives than positives. So x minus 5, x plus 1. That means we've got two critical numbers that give us 0 for the numerator. And they're not 0. So we've got 5 and we've got -1. Bless you. At x equals 5, x equals -1. Since f prime, when you plug 5 in, well, let's say equals 0, and f prime, make sure you got those primes on there, right? Equals 0. That's why they're critical numbers. It doesn't guarantee that there's a maximum or minimum there, but you got to look there. Can you guys think of as, like when I just said, it doesn't guarantee that it's a maximum or minimum. Can you think of a picture where you would get a graph, where you get a derivative of 0, yet it wouldn't be a maximum or minimum? Maybe not off the top of your head, but what if I had x cubed? What if I had a graph like this? And that, if this was x cubed. At 0, doesn't it look like you'd have a 0, right, derivative? And you would. We'd call it a critical number, but then you'd check into it. That's not a maximum nor a minimum, is it? It's just kind of an S curve. It just settles out for a little bit, has a slope of 0, then returns to rising. Okay. So you're thinking, what do we got to do with all this stuff? Here we go. The extreme value theorem. Kind of got 2 rules in a row here. It's a lot to take in. I just did it because it fits well on the page. We'll work through some. So the value theorem, extreme value theorem. If f of x, the function, is continuous on a closed interval, say from 7 to 12, from a to b, then f of x has both a global maximum or absolute maximum and a global minimum, absolute minimum. Okay? That's within this interval from, I could say -1 inclusive up to 3 inclusive. There will be an actual absolute max, absolute min. How do you find these absolute mins and maxes? Well, first thing, find the critical numbers. How do you find critical numbers? Derivative, set to 0 or where it's non-existent. 2, evaluate the function at each critical number. I do 2 and 3 together in a little T-chart kind of thing, and evaluate at the endpoints of the interval. Because if this was from A to B, maybe it goes like this. You got to check critical numbers there. Check the endpoint. I don't know, is that just disappearing lower or higher than the others? Your critical numbers and your endpoints will give you where the maximum or minimum will be. And 4, the greatest value when you check steps 2 and 3 together is the absolute maximum, the smallest is the minimum. So let's go through this here. Find the absolute maximum and minimum of the function on this interval. So this is when you could say absolutes, right? You're testing endpoints. Well, let's see about this one. We've got to do a derivative because it isn't given, is it? Yeah. Well, I'm going to pause. Let's get this going on here for the derivative. Okay, we're going to compare things. I'm not quite done grouping the derivative up, but hopefully you've worked yours out. First step, hopefully we're all matching on that. I might have made a mistake, so you guys check things out. Then I multiply, this is the difference of squares, x squared minus 1, so that's where this comes from. I make sure I use brackets with that 2, because later on it becomes 2x squared minus 2. I make sure I have this subtraction here. I start the bracket and work out x plus 1 all squared. 3 terms in that, because it's not a difference of squares. Then I distribute the negative sign throughout. If you don't put those brackets there, it's wrong. And That's a common error. Then I'm just going to group my like terms and we'll see what we got. 2x squared minus 1x squared, so x squared. There's only one group of x and it's minus 2. Minus 2 minus 1, so minus 3. Can we factor the numerator? Yep. X minus 3x plus 2, right? Okay. What I'm going to do though? Oh, okay, I'll just write it down. I'm running out of space now. I write bigger. It's the nature of this board. Now with that, which values give me a 0 for my derivative? 3 and 2, the numerator, right? So critical numbers at I can just see this, right? I'm setting the numerator equal to 0, so you can think 0 equals if you want. That's why I left that space here. Critical numbers at x equals 3 and x equals 2, since f prime of 3 equals 0 and f prime of 2 equals 0, okay? Now, that's the reasoning behind since. Is x equals 1 a critical number? Because the derivative doesn't exist there. So you'd think maybe it is a critical number. However, right off the bat, and I snuck this in here when you guys were flipping here, this function doesn't even exist at 1, so we can't consider it a critical number. It's definitely of interest because that's an asymptote there, right? So it's not a critical number because 1 isn't even allowed in the function. So the domain of your values of critical numbers have to be within the domain of the function. I haven't really solved this problem yet. I've only done step 1 of finding an absolute max or min. I've just found the critical numbers. It's 2. Evaluate the function at each critical number, and 3, evaluate at the endpoints. So, for space reasons, I'm going to move over here. I'm going to put 2 and 3, but I can call it test, endpoints, and critical numbers. So how do we do that? I'll set up a little t-chart. I like to go in numerical order. You know, my endpoints are 2 and 4, so let's see, 2, then my critical numbers between 2 and 4. By the way, for this, my critical numbers are 2 and 3, right? We solved that correctly, okay. And it's also my endpoint. If you had an end or a critical number of 5, it doesn't fall between 2 and 4, you wouldn't test it because it's not inside 2 and 4, the interval that we're testing, okay? So 2 is already written down. 3, and then 4 is the other endpoint. So it's not that you do them in order of integer order, like counting 1, 2, 3, 4, 5. It's strictly just test the critical numbers and the endpoints. Okay? So then, in the original function, not the derivative, because we know these give us zeros. 3 uses zeros. I'm talking zeros here. What is the original function's value? And we'll see quickly which is the maximum and minimum value. So x squared plus 1. Can we do this in our head? Okay? So I'm going to plug 2 into here. 2 plus 1 is 3 squared, that's 9, divided by 2 minus 1, so divided by 1. That's 9, right? Check out my arithmetic, I make mistakes. I'm doing this in my head. At 3, okay, so 16 on the top. 3 plus 1 and then square. 16 divided by 3 minus 1 divided by 2 is 8. 4 plus 1 is 25. 25 divided by 4 minus 1, 3. 25 thirds. Now, as a mixed number, because I got to be, can you guys quickly see 25 thirds? Is that bigger than 8? Is it bigger than 9? Is it smaller than 8? Is it smaller than 9? What is it as a mix? How many times does 3 go into 25? Help me out. What's that? 8 times. And there's 1 left over. It's 24, right? 1 out of 3 left over. Okay, so this quickly tells us it's not a maximum or a minimum, right? So your last thing is to make a statement. And I'm going to want a statement, okay? The critical number, our statement will be now you can use ABS for me, the absolute max instead of maximum. What is the absolute maximum value? From this list? 9. Say it's 9, you know. It isn't 2. It occurs at 2, comma 9. So if I ask what point does it occur at, you'd say 2, comma 9. The absolute maximum value is, I'm going to say it like this though, f of 2, which equals 9. That way I'm giving the full information. It occurs at 2, give that notation. The absolute minimum is f of 3, which equals 8. Okay? Good. By the way, you notice that domain restriction of 1 doesn't even fall inside 2 and 4 anyways? Okay. So your assignment, I've got some stuff for you guys to try out. It was a longer lesson today, but